Okay, so examples of ratio scale. We have height, which makes sense. Zero height means that they are not tall at all. There's no amount of height there. Time, same kind of thing. We can imagine zero time as there being no time left. And episodes of Grey's Anatomy. You can imagine if I watch 0 episodes of Grey's Anatomy, that is no Grey's Anatomy at all. So something that's kind of cool about ratio and really useful to us as we're doing statistics is that ratio can be used to multiply, or data that's in the ratio scale can be multiplied and divided because it has an absolute 0. So I can say something like, I watched 2 episodes of Grey's Anatomy each day for a week, and to know that since I had 2 days a week and there are 7 days a week, I can multiply them and say that I watched 14 episodes of Grey's Anatomy that week. Couldn't do that with any of the other scales. We have to have ratio to do multiplication and division. So that's it for scales. So finally, I just want to touch on something that's a little bit different than what we were covering before, statistics vocabulary, and something it's related to statistics, but it's not exactly statistics, and that's experimental design. So in experimental design, just kidding. So examples of the ratio scale. We've got height. You can imagine 0 height. That's no height at all. And you can measure something in like inches, so you can say that 1 inch, 2 inch, 3 inch, they're all the same amount of distance from each other. Time, 0 time, something we can conceive, no time left, so that makes sense. There's no such thing as negative time. And episodes of Grey's Anatomy, so I didn't watch any episodes of Grey's Anatomy last night, none at all, 0. And so the final thing about ratio scale is that because it has an absolute 0, you can use multiplication and division with data that's in the ratio scale. So that means I could say something like, I watched 2 episodes of Grey's Anatomy every day for a week. I can say that that's 2 times 7 days and know that I watched 14 episodes of Grey's Anatomy because it's ratio. I can multiply. And you can't do that with interval, for the record, or ordinal, or nominal, only with ratio. So here's a little chart that kind of shows the differences between the 4 scales of measurement, and I touched on each of these as I went through each one individually, but this is kind of just a succinct way to see the differences. You can see that as we go down, the scale picks up another yes. So nominal has only 1 yes, and then ratio eventually has 4 yeses. Those are the different characteristics between them. And remember that interval, because it has the equal differences, we can add and subtract. And ratio, because it has a 0 that is an actual 0, we can multiply and divide. We can also add and subtract with ratio because it also has equal differences. Alright, so finally I want to talk about something that's not exactly statistics but is related to statistics, and that is experimental design. So experimental design is used when we want to see how one variable affects a different variable. We target a certain variable and choose usually a topic of interest. So say we were doing some kind of drug trial to see if a new medicine actually cured an illness. We would have people that wouldn't take the drug and would take the drug. We would control that. We would give them, we'd have people that have the drug that we're giving to them as an experimenter, and people that don't have a drug purposefully, so that we can see if the sickness is being affected. In that scenario, our independent variable would be whether or not the patient receives the drug or not. That's the thing that we're in charge of, and it's the thing that we control as an experimenter to see if any changes happen in our dependent variable. So independent variable in this case would be the drug. It's the thing that we had control over. And the thing that's affected would be the sickness which is our dependent variable. Dependent variable is the thing that we measure after controlling and manipulating the independent variable, and the thing that we are interested in observing what has changed. So we don't interact with the dependent variable at all directly. We just look to see how it changes based on the things that we did with our independent variable. Another thing that happens in experimental design is that you have extraneous variables. So these are things that can affect the dependent variable that are not the independent variable. So maybe in this example, something like a healthy diet helps people combat sickness. That's not the drug that we're testing, but it is something that could have made someone feel better. So it affects our dependent variable. It affects maybe how sick they are, but it isn't the thing that we're targeting. It's a different thing affecting the dependent variable than our independent variable. Finally, we talk about levels, which is basically for any variable, it's the value of that variable. So the levels of our independent variable in that example would have been no drug or having a drug. Then depending on how we measure sickness, the levels were probably, you could say something like terminally ill or kind of sick, or yeah, these are obviously technical terms, or very well. Those are all levels. So well, it would be a level, very sick would be a level, terminally ill would be a level. And then for our independent variable, we have two distinct levels, sorry. In our independent variable, we have two distinct levels, having the drug, having taken the drug, or